Hello guys, so today we're gonna go through first step in PicoGK. Voxels are just three-dimensional pixels, basically. So if you have a picture is made from pixels, and voxels are basically 3D pixels on the picture. Let's put it that way. So it is basically a lot of little boxes. So lattices are objects in PicoGK that are very commonly used. These are objects that can be made out of lattices. And this is an example how to create new lattice. So today we're gonna do some custom geometry. So as you know, I make folder, and inside folder I make new .NET project, and I open this project with code . So over here I have project. Now in order to create custom geometry, I need to go inside this project and say, and I need to type package PicoGK. There we go, we have PicoGK over here. And now this is our main file that we run. We need to run our geometry with library go function from PicoGK, and it goes like this. And first is voxel size, and second will be our function we need to run, and we'll define that later. For now let's put it like this, and we will create new folder with that will be called geometry, and in that, and we will make copy of this file and move it to geometry, and we will rename it test geometry. So this is our program, this is our test geometry. So if you already read book from out, you know that you need to write code in classes and inside namespaces. Now I'll create namespace named geometry. In this namespace we need to define class, and it will be named like this, and our class needs function. So this is how we should structure all of our projects. So inside here we need to write our own geometry, and we will copy this example of lattice. So you'll see what we're gonna create. This is a new instance of a lattice called lat, and we add a beam to this instance, and we also render it with voxels. And now we need this function, and we will pass it voxels inside. And as you can see, this is red. That means we need to say that this code is using PicoGK, and also this code is using system numerics because we have vectors right here. So inside program we also have PicoGK, because this function is from this class is from PicoGK. From the previous tutorial, you know we need to define this class test and .generate. So if we put it just like this, this code says there is some error, and to test this, if we run it, we will also get some errors, and it says namespace definition, and we need to define this namespace. We will define it by using geometry right here, and it is still red, which means it will still give me errors. So these errors I'm getting are actually because I wrote this code kind of wrongly. So I'll debug it just for you to know if you have this same problem. So over here there shouldn't be semicolon, and you see there is yellow, and this should be with a capital letter, and also we need to fix it over here. So if we run our code like this, it says that object reference is required for non-static method. We are missing static here. So if we .NET run, we get our geometry and what this code actually means. So we have a starting vector and this ending vector, and this starting vector is over here. It is in our origin, and this second vector is somewhere down here, and it is 50 millimeters on the x-axis. So if you think that this is x-axis, it is 50 millimeters below. This 5 is a radius of this point over here. So this is 5 millimeters radius, and this 20 is 20 millimeters radius. So if you want to check, you can put 20 and 20 on the both sides, and you see we get pill-like object. And this true or false is actually this ending. So this ending, if you set it on the true, we'll have this rounded like shape on the end. If you set it to false, you have this flat. So as you can see, this is not perfect geometry on the edge. We can fix it by adding finer voxel size. So we put 0.05 over here and run our code. You'll see it is loading so much lower. I put 0.1 because 0.05 is too much. It takes too much time to load. But you see, this edge is so much finer right now. You need to really zoom in to see imperfections. So yeah, if we put like 1 millimeter over here, we'll get so large imperfections, and even this roundness is very badly defined. So if you want to make triangle like this, it is just lattice beams connected to each other in one instance of lattice. So if you want to run this code, you just come here and paste it inside this function, and there you go, there you have it. You have this triangle, and this is how you make triangles. So we go for Boolean operators. So we want to make a pipe, and as you know from this previous knowledge, you cannot create a pipe because you only add material. So we'll copy this code and see what is happening. So there is our pipe. So what is actually happening in our code? We create outside beam. An outside beam is actually with a radius of 10, and our inside beam is a radius of 8. If you want to visualize it, we can make it like this. And as you can see, this is our inside beam and this is our outside beam. As you can see, there is a little bit gap between them because I have just put a bar inside a pipe. This Boolean subtract actually subtracts whatever is inside this bracket to this object. So we subtract this object from this object. If we comment this line, we actually won't subtract anything, and we will not get this gap that we got before. So actually now if you put this lattice inside like some offset like 10, so it starts from 10th coordinate and ends to the 50th coordinate, and you uncomment this line, so we subtract it, and basically we don't need this last one because we want to visualize only this abstraction, and we just got a cup. So if you want to make a lot of beams inside a sphere, so basically you make a lot of beams with for loop like this. This is for loop. On top of this code I showed you earlier, you create a sphere and you just Boolean intersect. So there is difference between Boolean intersect and Boolean subtract. Boolean subtract will actually remove anything that is intersecting from two objects, and you need to be careful when doing that because there is target object and object you want to keep. But yeah, these tutorials are similar to the previous ones, just Lin introduced this offset function, so you can create a pipe a little bit different way, so we can visualize that ourselves. There we go, we have a pipe. It has round edges. So what we actually do here, we make a new lattice, and inside this lattice we fill it with 3 beams, as you can see, and we create voxels out of this lattice. Now we create this outside pipe that has offset of 2, and we can actually visualize this inside and outside. And as you can see, this is how it looks like. Maybe it's more useful to visualize outside, and yeah, that's it. With this you can also do subtraction of voxels. So inside this tutorial you can also see other stuff, how Lin builds it and how he builds it. Maybe this one is interesting. So if you want to make something that is not straight, like straight pipe, you actually make it like this. You need to make a sphere, not a beam, and you place a sphere on a large amount of steps. Okay guys, so as you can see, this is the spiral that Lin wrote. And if you place this angle, so this for loop is repeating much more or less. So according to this, we will get only 3 spheres inside. And as you can see, we got 4, because this is 0th and first one and third one. Because for loop goes from 0 and it increases by 1, so next loop it will be 1, next loop will be 2 and 3, and this is pi, and pi is 3.14. So it will actually draw, as you can see, 4 spheres. And if you make this step like 0.01, as you will get fine spiral line that is basically all spheres together. So that is what is happening inside this code. You can make a helicoid like this, and for it to be larger, let's put it like 5 over here. This is basically helicoid, and you can see how smooth it is over here, because we put here so small of a step, so all spheres just merge into one another. So you can also make painting pictures like this. You can make boxes or like flat planes or something like this or something like this. You can deform this flat plane like this with this code, and you can deform it in much more different ways. I won't go in depth of this because for now it is not necessary. We will go in depth a little bit after, but it is just functionality what you can do with PicoGK. So in order to really understand what is actually happening inside this code, we need to go in depth of shape kernel, but this video will be too long, so we will talk about it in the next videos. So that's it for me for now, and see you in the next tutorial.